Hey guys, what's up? See, I'm here with the very next topic, and this is like very close to completing the chemical properties of amines. And what right now I'm doing an explanation for you, because the topic itself is a question, a very important question for board exam, for any other exam you might be considering you are having. What this question is, this is a question called why aniline do not undergo friedel reaction, right? Before I do that, I wish to tell you, don't be surprised because of my cap right here, because it's too cold here in Delhi, and due to this cold wave, even my nose is swelling and really causing inconvenience. Anyway, so I have explained you the question. Now I have to explain you why aniline do not undergo friedel reaction. So friedel, you do understand that if you talk about aniline, this is what your aniline is, right? So this is your aniline is, and you do know that aniline has a lone pair on the nitrogen. And this reaction can be, classified into two, category. This can be classified into two category. Probably you do know what I'm talking. One is called, friedel acylation, and other one is called friedel alkylation, right? But if I brief the answer, I would say there is no product, and that is the topic. So in either of these cases there is no product forming, and I am about to explain you why there is no product. One thing you do remember, that this reaction is carried out in presence of a Lewis acid like AlCl3, right? This is your Lewis acid. So I tell you exactly, this AlCl3 is actually responsible for not letting the reaction proceed, right? And also because the amine group is highly reactive. What happened here, in case you remember the actual mechanism, a friedel reaction is initiated by the AlCl3, where this AlCl3 react with an alkyl halide. Maybe I should write like, okay, let's make it Cl, alkyl halide or acetyl chloride. So let me repeat back. This AlCl3 is responsible for initiating both of these reactions. And how this AlCl3 start is that it causes the formation of electrophilia. Let me tell you, this is what happens. This bond breaks and you have a electrophilia. Similarly, this bond when breaks, you have another electrophilia. So this cleavage of the bond is due to the AlCl3. But what happened in both of these cases, these cleavage are not possible. Why? Because the AlCl3 is itself electron deficient, while the amine is overexcited because of presence of that lone pair. And that nitrogen is so eager to donate its electron, right, that it donates the electron to AlCl3 itself. And what happened, AlCl3 gets busy into something and it forgets the actual reaction to start, which is breaking of the bond here. So what happened, this AlCl3, instead of reacting with these two, it goes with there. So what happened here, this come up right over here and you get a salt coming up here. So what that salt is, this is what the salt is. You have your benzene, there you have your NH2, and what happened, nitrogen, since has given its electron, and aluminum chloride, since it has taken the electron, So this salt is formed. What is this? This is a salt. And due to the formation of this salt, actually, there is no AlCl3 available in order to initiate the reaction over there. And that's why the reaction stops. So how would you conclude finally? That because NH2 is highly reactive functional group, while AlCl3 itself is a electron deficient Lewis acid. So before the AlCl3 could generate the electrophile, it reacts with the amine group and form a salt, and after the salt is formed, the reaction stops. There is no further reaction. There is no alkylation, there is no acylation. So that's the actually, the answer for my initial question is. So I hope you have understand what I was trying to make you go through. In case you have done, do let me know with your comments and all. I would say thanks for watching. Take care and good night.